Assalamu alaikum, my dear students. Today we will start a new lesson. It is about rational functions. We will divide this chapter into many parts. So please take notes, write the rules, and solve the applications at the end of each part. Part 1, Objectives. Define a rational function. Define a vertical asymptote. A rational function is defined as a ratio of two polynomials, f of x equals g of x over h of x, where h of x is different from 0. Examples of some rational functions. Let us see the graphs of some rational functions. This rational function has this graph, and this is the graph of another rational function. Now this is the curve of the first function f. It has equation x plus 3 over x minus 2. Note that x minus 2 is different from 0, then x is different from 2. Then the domain of definition of this function f is from negative infinity to opened union 2 plus infinity. But what are these two straight lines? These two straight lines are called asymptotes. This is a vertical asymptote and this is a horizontal asymptote. Let us start by the vertical asymptote. The vertical asymptote, it is a vertical line. And since it is passing through 2, then it has equation x equal 2. But how can we relate this straight line with the curve of the function f? Let us look at the point m, and suppose that m is a moving point on the curve of the function f, and the coordinates of m here are 1, minus 4. Let us see what will happen if x of m approaches 2 from the left. Look please at the coordinates of the point m. X of m is approaching 2 from the left, and look at y of m. Y of m is decreasing. So x of m 1.07, 1.08, and y of m is decreasing. So we can say it as a limit as x of m approaches 2 from the left, y of m is tending to negative infinity. Now let us see it from the other side. Suppose that point m is here and it has coordinates 3, 6. Let us see what will happen if x of m approaches 2 from the right. What will happen to the y of m? Please look at the coordinates of point m. And notice that x of m is approaching 2 from the right, 2.7276. And look at y of point m. So we can say it as a limit. As x of m approaches 2 from the right, y of m is tending to plus infinity. So now we have seen graphically that limit as x tends to 2 and x is less than 2 of the function is minus infinity, and limit as x tends to 2 and x is greater than 2, it is equal to plus infinity. So what is a vertical asymptote? The vertical asymptote is a vertical line that the function approaches but never intersect. But why 2? Is it because 2 is a root of the denominator? Yes. If 2 is a root of the denominator, then x equals 2 is a vertical asymptote. But how can we get this result by calculation? We can also find limit as x tends to 2 and x is less than 2 for the function f of x, which is x plus 3 over x minus 2. We replace x by 2 and we continue, and it is 5 over 0 minus, since x is less than 2, which is minus infinity. Also, we can see the limit as x tends to 2 and x is greater than 2 of the function f of x. We will get 5 over 0 plus, which is plus infinity. So also the same result. So we can have it as a rule. If limit as x tends to a and x is less than a of a certain function is equals to plus or minus infinity, or if limit as x tends to a and x is greater than a of a certain function is equals to plus or minus infinity, then x equals a is a vertical asymptote. Let us solve the following example. Given a function f of x equals x squared over x squared minus 1. Find the domain of definition of f. Find the following 4 limits. Deduce the equations of two asymptotes. Answer. Concerning the domain of definition, we take x squared minus 1, the denominator different from 0. This means that x is different from minus 1 and x is different from 1. Then the domain of definition is from minus infinity minus 1 opened, union minus 1, 1 opened, union 1 plus infinity. Now we find the limit as x tends to minus 1 and x is less than minus 1 for the function. We get 1 over 0 plus, which is plus infinity. And limit as x tends to minus 1 and x is greater than minus 1, we get 1 over 0 minus, which is minus infinity. Then we deduce that x equals minus 1 is a vertical asymptote. Now we take the limit as x tends to 1 and x is less than 1 for the function. We get 1 over 0 minus, which is minus infinity. And limit as x tends to 1 and x is greater than 1, we get 1 over 0 plus, which is plus infinity. So x equals 1 is a vertical asymptote. Then this function has two vertical asymptotes, x equals minus 1 and x equals 1. Let us look at the curve of this function. This is the curve of the function f. It has two vertical asymptotes. Let us look at the limits graphically. We have limit as x tends to minus 1, this is minus 1, and x is less than minus 1, it is plus infinity, and limit as x tends to minus 1 and x is greater than minus 1, it is negative infinity, and limit as x tends to 1 and x is less than 1, it is minus infinity also here, and limit as x tends to 1 and x is greater than 1, it is plus infinity. Now, please solve the following application. Given this function f of x equals x squared over x squared minus 4x plus 3. Find the domain of definition of f, find the following four limits, and deduce the equations of two asymptotes. Answer. Number 1, x squared minus 4x plus 3 is different from 0, then x is different from 1 and x is different from 3. So domain of definition is negative infinity 1 opened, union 1 3 opened, union 3 plus infinity. Number 2, limit as x tends to 1 and x is less than 1, it's a plus infinity. And limit as x tends to 1 and x is greater than 1, it is minus infinity. Then x equals 1 is a vertical asymptote. And limit as x tends to 3 and x is less than 3, it is negative infinity. And limit as x tends to 3 and x is greater than 3, it is plus infinity. So x equals 3 is a vertical asymptote. Then this function has two vertical asymptotes, x equals 1 and x equals 3. Now look at the curve of this function. It has two vertical asymptotes, x equals 1 and x equals 3. Thank you for watching.